Hi, my name is Benjamin Turner, Assistant Professor at Texas A&M University, Kingsville. It's my pleasure to share with you the chapter that I wrote with Dr. Vince Tidwell from Sandia National Labs entitled Connection and Integration, a Systems Approach to Exploring Acequia Community Resiliency. The purpose of the chapter was to describe our model of acequia operations and then test the model under different conditions or what we call counterfactuals or what if questions. First, a little bit about where this model came from. It was developed using a variety of knowledge and data sources, including interviews with Acequia stakeholders and the expertise of the entire Acequia research team. With that input, the model was conceptualized and developed and then calibrated to a variety of data sources, including some high-level ones, agricultural costs and returns, hydrology and surface water groundwater interactions, and the US Census data. Once we were confident that the model was behaving the way that we've observed acequias behave in the real world, we moved on to scenario analysis, which is asking those what if questions to analyze what might happen given changes in regulation or policies, economics, or climate drivers. What is included in the model? We've included some references here for the full documentation, but the high level components of the model are the hydrology, influence on the acequia, how the acequia drives the local rural economics in the community, the interactions with regional pressures and ag policies, but most importantly, the feedback on how the acequia shapes the hydrologic and local ecosystem, how economics and community both feedback and influence the behavior of the acequia. What we call in the chapter natural capital for the hydrology and the ecosystem, economic capital for those agricultural and grazing products and services that the acequia provides as well as social capital or what's called mutualism through preserving community participation. So those are the high-level feedbacks included in the model. The model itself was hundreds of variables and dozens of feedbacks, which is why I include the references there for further documentation. What are the high-level insights that we've learned so far through this modeling approach? Initially, we found a few relatively sensitive or influential variables that have wide-ranging impact across an acequia's agriculture, community, and hydrologic services. Those included the income effect on time in agriculture. In other words, how does one's income affect the amount of time they're willing to spend on acequia agriculture? And then based on that time, the time that they're willing to commit, what does their land use preference look like given their time constraint? The second set of variables that we found to be of wide-ranging impact was the effect on employment on participation in the acequia activities. So how reliant are individuals on outside employment, outside of the community, as well as the farm size effect on participation in the acequia. So what's the critical size of the farm and how does that drive their willingness to participate? The next set of analyses that we conducted looked at climate drivers or climate change. And what we found in that analysis was that earlier peak flows that are expected with the changing climate in the region, coupled to higher valued crop selection, which is a potential coping mechanism in the acequia, actually led to improved economic and community resiliency. However, with the earlier peak flows and the shifting hydrologic conditions, that resiliency was eroded as downstream water demands and downstream water pressures were exerted on the acequia. The good news was, however, that community cohesion, or what we call mutualism, actually minimized that erosion. It minimized that risk of the downstream water demands or water pressures. And then finally, what we did in this chapter was look at the adaptation success of various coping strategies to some of the economic and climate drivers that we looked at in the two previous analyses. And what we found there is that the immediate trade-offs in ecosystem goods and services often differ from the long term. So coping strategies like changing grazing strategies and herd sizes in response to pressure, or potentially ditch lining in response to some short-term climate or hydrologic pressure. Those things likely work and are very successful in the short term. However, it actually led to reduction in long-term sustainability of the whole swath of acequia functions and services. So it'd be interesting to hear how these results align or not with your own experience and observations. With that, I just wanted to say thank you for your time and attention. And this is just a list of some collaborators that I and others joined together to produce this model, along with, of course, I want to thank Dr. Vince Tidwell for his collaborative effort on this as well. Again, thank you for your time.